Today we will look into item 44 of effective Java, which is regarding favor the use of standard functional interfaces. In the previous items we saw about the lambda expressions and the usage of functional interfaces. Basically, after implementing the functional interfaces, we get the function objects, which we treat them as lambda expressions. Java provides a lot of functional interfaces which are inbuilt, so we can reuse them rather than creating our own functional interfaces. So in this item we will look into what are the inbuilt functional interfaces and in what case we need to create our own custom interface. To start with, there are 43 functional interfaces which are provided by Java, but that is overwhelming and not easy to remember. But we need to go with basic functional interfaces, and from them we can derive other function interfaces. So the basic function interfaces are unary operator, binary operator, predicate, function, supplier, and consumer. Let's see what they indicate one by one. The unary operator. So this functional interface takes one argument and returns the same type. Right? If it takes integer, so it will return the integer as a type, and it will do some operation over that. So example will be like, for example, in this method reference to lowercase, so we are providing a string as an input and we are returning a string as an output. So here the logic will be to convert that into a lowercase. Similarly, for binary operator, so it accepts two arguments of same type and returns the value of the same type. For example, the big integer add method reference. Right, so it accepts two integers and returns an integer, the big integer value. So let's just, for example, let's see the add method here. So you can refer this. So we are providing the parameters types of same type, and the similar type is returned as a return value. The next one is predicate, so which accepts an argument of some type and returns a value of boolean. Like, for example, collection is empty. Function, so function accepts a value of some type t and returns another value of type r. For example, arrays as list. Right, so arrays as list which accepts an array as an input and returns an list as an output. Supplier, so supplier, it won't accept anything but it will return you a value, like for example instant now method reference. Consumer, consumer doesn't return anything, and it just consumes a value of some type. So even these names are self-explanatory. Right, unary operator which operates on a single argument, right? Binary which operates on two arguments. Right? Now, from these six basic functional interfaces, we derive few more functional interfaces. So most of the functional interfaces which are derived from these six interfaces are dealing with primitive types. Right, let's go through one by one. I will just try to give the overview of the various function interfaces. The whole of this bunch of function interfaces combined to form 43 function interfaces. So let's see one by one. So unary operator and even all the basic six function interfaces, they provide specialized function interfaces to operate on the primitive types. right? Primitive types are int, long, and double. So we have variants for each of the function interfaces. Like for example, unary operator, we have int unary operator, long unary operator, double unary operator. What it does is it will take an input of type int and returns you an output of type int. For example, here for int unary operator, you can see that it takes an input of type int and returns int type. And also note that there is no generic uh, method type specified here. That is because the method itself, the function interface itself says that it accepts int and returns int. Similarly, for binary operator, we have int and long and double variants. So same logic applies here. For predicate, we have int, long, double variants. For function, we have the same. And for supplier also, and consumer. Now we will look into some other variants. For function, we have some more customized function interfaces. For operating on primitives, we have few more function interfaces for function. We understand the function accepts a type T and returns another type R. So let's say we have a requirement where we want to accept a primitive type of one type and return another primitive type. In those cases, Java has inbuilt function interfaces which we can reuse. For example, long to int. Here, long is the source type. That's the input. Int is the result type, right? That's the return type, right? Source to return. So this is the format we need to remember, right? Source to return. Here source will be long, here return is double, long to double. Like this we have variants for all the primitive types. And there is also few more variants which author specifies in the book about double to obj. So like from primitive type as an input to object as an return type. But unfortunately I couldn't find these variants in the JDK. So I don't see double to obj. So these variants I couldn't find. So I'm not sure, maybe these are planned in the Java in the upcoming releases. So let's see, look into another inbuilt functions which Java provides, where we have two arguments. Right? Let's start with function. So function which accepts two arguments and returns a value. So here function accepts two values of different types and it returns you a primitive value, right? To int by function. So we are calling this as a by function, right? Too long, too double. And now for consumer also we have variants for which accepts two arguments, right? So here we have like obj double consumer where object reference of type T and a double, these are the two arguments which it accepts. So obviously consumer, as I said earlier, it will just consume the values. So similarly we have obj int consumer, obj long consumer. So we have these two argument variants for other basic function interfaces. Like for predicate, like we have by predicate, by function and by consumer. So by function we already discussed here and their variants. So by predicate and by consumer. And also we have one special type which is Boolean supplier. Right? Supplier, we already know that it doesn't accept any value, but it will return you a value. So here in this case it is returning you a Boolean type. Right? So this is different from predicate. Predicate also returns you a Boolean, but predicate accepts a value, but here it doesn't accept, but it will return you a value. So thus we have in total 43, but these three function interfaces I couldn't find in the JDK. If somebody has any idea about these three, so they can mention in the comment section. Having said that, so in most of the cases, we should be relying on the inbuilt function interfaces. In few rare cases, we might need to implement our own function interfaces. Like for example, if you want to accept three arguments, so there are no function interfaces, inbuilt function interfaces which can accept three arguments. In those cases, we can implement our own function interface. Method interface. So it's a functional interface which has method compare, which accepts two arguments and returns a type integer. Instead of writing this interface, the Java authors should have used the by function interface, right, which accepts two arguments and returns a type. So why they choose to write the comparator interface? Although when they were writing the comparator interface, there was no concept of function interface, even it would have been existing, they should be writing the custom interface rather than using the function interface. Why so? So one of the reason is the comparator is widely used across the Java library. So by writing the custom interface, we are providing a strong documentation and Java doc for that interface. And another reason is we are providing a strong contract, like whichever the classes which implement this interface, we are providing a contract for them. Like, so we are providing two arguments of same type and returning you a integer type, and what exactly we are expecting out of the implementation. So as it is described in this Java doc. Another advantage with custom function interface is we can write our own default methods. As you can see, we have default methods here, which will do some extra logic which is optional, and the API implementers can leverage with the default methods. So if we have these three needs, then we can go with the custom function interface. Having said that, in most of the cases, the inbuilt functional interfaces are sufficient. In rare cases, we might need to implement custom function interfaces. End of this item, author mentions about one thing which we need to take care when implementing the function interface. That is about overloading. When we have overloaded methods, we should be cautious enough to not to have the function interfaces at the same argument position, which may lead to ambiguity. For example, in executor service, we have submit method. As you can see, the submit method accepts callable and runnable right here. So this is sometimes confusing for the user, and we may end up writing a callable and casting it to runnable, which may lead to ambiguity. So to avoid this confusion, we should avoid writing overloaded methods wherein it accepts the functional interfaces at the same argument position. With that, in overall, always prefer the inbuilt functional interfaces which Java provides. So in total there are 43. In rare cases, prefer to write your own custom function interfaces wherein you have the needs as we have the need for like comparator interface. Hope this item is useful. I will see you in the next item. Thank you.